This week on the show, we cover storage changing software, what makes Unix special, what you need may be pipeline plus Unix commands, running a bakery on Emacs and Postgres, the ultimate guide to memorable tech talks, lightweight contexts, and more in this week's episode of BSD Now. BSD Now, episode 291, Storage Changes Software, recorded for the 27th of March, 2019. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Ju.
And we're almost back from Asia BSDCon by now, when you watch this episode. But we'll have headlines for you this week, starting with tracking a storage issue led to software change.
Yes. So this is a post by some of the data center engineers at Gandhi, the domain registrar and hosting provider. And in their efforts to modernize their data center, they upgraded their storage appliances from an old version of Nexenta to FreeBSD. And they say, currently, we use the NFS protocol to provide storage and export the file systems for our simple hosting service. And the FreeBSD kernel includes an NFS server for that purpose. The problem they saw was that when migrating disks for the simple hosting service, instances from their old data center, they noticed high CPU load spikes on the new storage units. To understand what was causing it, they ran PMC-stat, which gets performance counters out of the CPU. So these are hardware performance counters, and used that data to generate flame graphs so they could see what was up. And they saw that the load was being caused by lock contention in some of the kernel parts of the NFS server.
Mm-hmm.
So once they knew where to look, they used DTrace to analyze the requests that were triggering this lock contention and added some missing NFS metrics. For instance, they were able to list, which hosts were the top talkers for each type of operation in NFS, and they realized too late that the NFS server didn't seem to be scalable enough for their workload. So they said, since the load spikes were happening with increasing frequency, we had to find a solution pretty quick. 5 years after launching our web hosting product, we questioned whether NFS was the right answer for the simple hosting instances. Would exporting data through a block device using something like iSCSI be better? So it seemed like it would be, but it would mean removing some customer-facing features. Like currently, they provide access to their snapshots via the SFTP by using the built-in ZFS hidden directory thing. In order to keep all these features, we had to stick with a plain file system export rather than using a block device. So say, given that the code is pretty hard to understand and that any bugs would impact the entire system, solving the load issue by fixing the kernel seemed like it might be too complicated and risky, especially with all the customer data on the line. But they decided to give it a try anyway. As a first step, we made sure the kernel part of the NFS server was built with all the as a dynamically loadable module. So instead of having the NFS server built into the kernel, they made it as a loadable module so that they could unload it and load a new version of it without having to reboot the system. So that the NFS outage would be a couple of seconds instead of minutes. This allowed them to iterate and try things a lot more quickly.
Okay, yeah.
In general, I'd like to see more and more of that happening in FreeBSD. I know Warner Losh has been working on the minimal kernel that moves a lot of drivers to be like that, but some features like the NFSD, it might make sense to do that as well. And thanks to Gandhi, they've upstreamed their patches that fix issues with loading and unloading NFS as a dynamic module.
Cool.
So they said at that point, they found many potential lock contentions in the code that could explain the load issues they were seeing. Most of them were related to the NFS feature delegations. And since fixing these contentions would require rewriting most of the code, they thought, well, what if we just don't use delegations? But it turns out there's a bug. An important lock contention related to delegations was still happening even once they had disabled delegations. A lock was taken when processing the getAttr NFS operation, which gets the attributes of a file, which is what NFS has to do when you use the stat syscall on a file, which is, when was this file created, how big is it, and the basic information about a file.
Mm-hmm.
So even though no write delegations are being granted, it was taking a lock to be able to do that, which seemed to not make sense. Especially since the getAttr operation is used to retrieve file attributes, like we said for stat. So they proposed a patch that was accepted upstream to reduce the contention by not taking that lock if there's not going to be a delegation. But even after that, their load issues were still there.
Not so good.
There was still quite a bit of lock contention.
Yeah.
And all of it was related to access conflict checks. So we reworked our internal architecture to only have a single NFS client per export in an attempt to remove some of that access conflict code. Since this was a pretty risky solution, we started looking at an alternative in parallel. So they thought about using Samba to replace NFS, but it seems that its scalability is probably even worse, so they didn't really push that. NFS v4 supports delegations and has been in production for a while without major issues, and it looked like the safest thing to do. So they kept looking, and they found the NFS Ganesha project, which is a user space NFS server.
Okay.
So it provides an implementation of the NFS protocol, but it's all done in user space. We figured that running this kind of server in user space would be a huge boon to us, since it would allow us to roll updates by just restarting that service without having to reboot the whole system. I think they've mostly got the same thing with the NFS as a module, but not if the new changes to NFS happened only in FreeBSD 13 or whatever. Anyway, unfortunately, the project does not actually support FreeBSD currently. It has a bit in the past, and most of the code is still there, but it had fallen out of maintenance. But Gandhi took up the work to update and complete the port to FreeBSD to make it fully usable. So at first they were unsuccessful with compiling it, but they managed to solve the problem by working around some FreeBSD-isms, like the getAttr info is different on Linux than it is on BSD, and you have to use different functions for getting error messages and so on. But after making these adjustments, the code compiled successfully. However, they noticed that some special syscalls were required to make the user space bits work. These syscalls don't exist in FreeBSD, and therefore in order to implement a multi-threaded user space file server, we need to access file systems using different credentials, like usernames and group names and so on, which are required by clients through that NFS protocol. But according to the POSIX standard, all threads within a process must share the same credentials. On Linux, credentials are implemented on a per-thread basis, and syscalls only change the current thread's credentials. But the GNU libc keeps POSIX compatibility and wraps these syscalls to apply any changes to all threads of the current process. On FreeBSD, by contrast, credentials are only implemented on a per-thread basis, are also implemented on a per-thread basis, but syscalls do change credentials on all threads within the process, thus preventing changes for a single thread. So the NFS protocol uses file handles to identify files that it's accessing. And so the idea was to have some syscalls related to file access use these file handles. For example, in Linux, there's an open by handle at syscall, but FreeBSD doesn't have something quite similar. Half the code already existed in the get file handle syscall, and so they just used that as a base and wrote the new module. So what they've done is created a new kernel module that adds the syscalls that you might need, or that you do need, to use the Ganesha user space NFS server. So after that, they did performance testing and found that it was much better. And they've made both of these available as ports. So there's NFS-Ganesha and NFS-Ganesha-K mod available in the FreeBSD ports tree, and you just install those and load them, and you can use the user space NFS server.
Very nice.
And they said once packages have been built, they started deploying the solution by swapping one storage unit at a time. We were able to validate within a few months and fix issues as they arose, including a memory leak or the cache getting outsized. In order to migrate existing storage units to Ganesha, we had to unmount all exports on clients because of the differences in the file handle structure between Ganesha and the FreeBSD kernel. But otherwise, file accesses would return errors. So they couldn't just stop NFSD and start the different NFSD. They had to get the clients to unmount. And we had to shut all instances related to impacted storage units, stop NFS, generate the Ganesha config file, start it, and then get all those instances to remount. But as you can see from their little graph here, CPU usage went way down once they did that.
Oh yeah, significantly. And it stayed that way.
Mm-hmm.
There are no spikes anymore.
So they say, we finally solved our load issue on our storage units, and surprisingly, it performs much better than the kernel server, and we're enjoying the benefits. Although Linux and FreeBSD may look the same, since they share the same Unix roots, we found that there are many differences, and we had to look deeper into that. And they're hoping to see NFS Ganesha have a bright future.
Mm-hmm. Yeah, very nice. Thank you, Gandhi, for that work and also upstreaming it into a port or into.
Yep. So they made it available on GitHub and made a port. And they upstreamed a bunch of other related fixes, like making our NFS server be able to load as a module.
Mm-hmm. Very nice.
And they also mentioned that they're hiring FreeBSD people and sysadmins and so on, although only in French by the look of it.
Mm-hmm. Yeah, so that's contributions in changes in hardware, making appearances in software. Next up, we have what makes Unix special over at softwaredevelopment.site. And it starts with, ever since Unix burst onto the scene within the early 70s, observers within the PC world have been fast to put in writing it off as an unusual working system designed by and for knowledgeable programmers. Regardless of their proclamations, Unix refuses to die. Means again, in 1985, Stuart Seifert puzzled if Unix would turn out to be the usual working system of the longer term on the PBS present, the Laptop Chronicles, though MS-DOS was effectively in its heyday. In 2018, it is clear that Unix actually is the usual working system, not on desktop PCs, however, on smartphones and tablets. It is also the usual system for net servers. The actual fact is hundreds of thousands of individuals all over the world have interacted with Linux and Unix programs daily, most of whom have by no means written a line of code of their lives. So what makes Unix so beloved by programmers and different techie sorts? Let's check out a few issues this working system has going for it, and some of the backgrounds on Unix, the historical past of Unix from Bell Labs to the iPhone. So first thing they have is, of course, the shell. Personal interface design has come a good instance for the reason that early days of computing. There are command line interfaces, graphical interfaces, gesture-based interfaces you identified. So most critical customers nevertheless favor the nice old school command line. For one factor, since Unix-based working programs typically reside on servers, utilizing text-only software program reduces the overhead. And as a substitute of a devoted monitor, keyboard and mouse to a server, directors can log in remotely by a way of SSH, both into the machine straight or incessantly right into a console server, which exhibits working system messages and lets them reboot the machine. These customers then spend most of their time within the shell, which is the system that takes enter and interprets it into actions, both operating packages or configuring the system. It is much like the MS-DOS immediate or the outdated BASIC languages on 8-bit computer systems, just like the Commodore 64. Then, on Unix and Linux programs, the person has a selection of shells. The default within the Linux world is Bash, for born once more shell, pun on the creator of one of the mainly authentic shells, Stephen R. Bourne. Different common shells are the Z shell, the C shell, and the Korn shell, named after David Korn. So this exhibits the choice of modular design within the Unix world. Every part up from the shell to the graphical personal interface is simply one other program, and elements will be swapped out simply. It additionally permits for a strategy to grow based mostly on small instruments. And so next thing is that every part is a textual content file One of many issues that characterizes Unix-like programs is their dependence on textual content information, contrasted with different programs of the time that used opaque binary information to retailer configuration info. The concentrate on textual content irritated some customers of different programs. However, Unix customers prefer that approach. The frequent threat was wordsmithing. Suspiciously excessive proportion of my Unix colleagues had already developed, in some prior confession, a consolation and fluency with textual content and printed phrases, Thomas Scoville wrote. They had been adept readers and writers, and Unix performed handily to these strengths. Unix was, in some senses, literature to them. Instantly, the overrepresentation of polyglots, liberal arts sorts, and voracious readers within the Unix neighborhood did not appear so mysterious and pointed the best way to a deeper situation. In a world more and more dominated by picture tradition, TV, films, JPEG information, Unix stays rooted within the tradition of the phrase. Then we have small instruments. The shell, and having all the pieces as a file, lends itself to a different main attribute of Unix growth, doing complicated duties by constructing pipelines out of small instruments. The entire shell has a pipeline character, or pipe, which sends the output of one program into the enter of one other. So the input is taken there. And this makes stringing collectively packages simply. Supposing the sorted checklist of all the customers logged into the system with no duplicates, as customers can log in a number of instances. There is what you would appear to be doing. So who pipe that to minimize -d -f1, and then pipe that to type, and then pipe that to unique. And there are similar exercises like counting words and listing the most frequently appearing words in a file or things like that. So though it appears unusual, it exhibits the facility of this model of growth. In the event of you determined to implement this from scratch in C, you could be thousands of traces of code. This model of growth has been known as the UNIX Philosophy. You may wish to try Mike Gankart's guide, Linux and the UNIX Philosophy, in case you're interested. So why Unix lives on? So why has this quirky working system endured within the face of challenges from the likes of Microsoft? The reply is straightforward. Many builders discover it as a refreshing different thing of the monolithic instruments like IDEs and languages like Java. As a substitute of being handed down from one excessive by one company, fashionable Unix variations develop organically. Science fiction author Neil Stephenson referred to Unix because of the Gilgamesh epic of the PC world in his essay Within the Starting Was the Command Line. So if it's a continued success story is any indication, Unix will proceed to draw many extra builders within the years to come back. And time for the news roundup this week. We have what you need. What you need may be pipeline plus Unix commands.
Only. Right. So this is a post by an OpenBSD hacker we've talked about before, Nan Zhao. And he's referring to this other post called Taco Bell Programming, which says, every item on the menu at Taco Bell is just a different configuration of the same 8-ish ingredients. This is the same periodic table of meat and produce. The company pulled down $1.9 billion a year. And they're talking a little bit about, suppose you have millions of web pages that you want to download and save to disk for later processing. How would you do that? The cool-kit answer would be write a distributed crawler enclosure and run that with the JDK on EC2 and, hand out jobs via message queue like SQS or 0MQ and yada, yada, yada. Whereas the Taco Bell answer would be piped list into xargs and feed it to wget. Maybe add split and rsync to distribute the list of web pages to different machines. And then, you have a 10-line shell script and you're now downloading all those web pages.
Yeah, easy enough.
Yeah, and then when you want to work on it, you don't need Hadoop, map, reduce, and so on. You just use find on the directory, print out the file names, set parallel to 32, and pipe them into your process command. And, 32 concurrent parallel processors of one file each, and done. And so on. So they say Taco Bell programming is one of the steps to the path to Unix Zen. So back to the original post. So they came across this post and was thinking about it a bit. The post mentions a scenario where you would, instead of using Hadoop, you might just use xargs and a shell script. This came up a couple of years ago at a BSD Can. One of the talks was about this Japanese method of using shell scripts for stuff. And they found that a job that took like 7 minutes in the shell script took 45 minutes in Hadoop. And that, some Unix machines with 10 gig and some shell commands is actually usually faster.
Yep.
So Nanjiao has an extra example. He says, this reminds me of a similar experience. Last year, a client wanted to process a data file which had 5 million records. After some investigation, no novel techniques, and a 10-line awk script, and it worked like a charm. What surprised me more is that awk is just a single-threaded program. There's no concurrency involved. The IT field never lacks new technologies, cloud computing, big data, high concurrency, etc. However, the thinkings behind these fancy words may date back to an era when Unix first arose. Unix command line tools are invaluable treasures. In many cases, picking the right components and using pipelines to glue them together can satisfy your requirement perfectly. So spending some time in reviewing the Unix command line manuals instead of chasing state-of-the-art techniques. By the way, if your dataset can be disposed by an awk script, you shouldn't be calling it big data.
Yeah. There's a bit more things involved in big data, but for the easy text processing parts, Unix can do it. And I think Cantrell has a talk or mentioned it once that he had like a slide where he said basically Donald Knuth versus some of the developers in Unix just fight and just had this command line that basically did the same that Hadoop does.
Yep. But yes, like we saw in the Taco Bell programming link there, split, rsync, awk might be the answer.
Yeah, that gets you a long way already.
Yep. With xargs being able to run multiples in parallel, you could literally, if you split the file into reasonable sized chunks and then process them in parallel, and then you can just recombine those outputs and do the final processing, it's basically the same thing as a MapReduce. It depends a bit on scale, but...
Right. Yeah, without the network in it, then there's also that overhead and the distributed systems aspect. But if you just have it on the local machine and the file system does, or the data fits in memory, then by all means use the local machine.
Well, yeah, the data doesn't have to fit in memory. Just the working set of the data needs to fit in memory.
Yeah, that's more precise.
If you have a 1 terabyte file, you can still process it with awk. And, if you split it into some chunks, that might help, but...
Yeah. Okay, yeah. So let's talk about something else, because you can also run a bakery on Emacs and Postgres, according to this article here. So just over a year ago, the author here in this blog finally opened the bakery he'd been dreaming on for years. It's been a big change in his life, from spending all his time he sat in front of a computer to spending most of it making actual stuff, and stuff that makes people happy at that. It's been a huge change, but he can't think of a single job that's ever made him happy as this one. So one of the big changes that came out of it was going pro, that was suddenly he's having to work on how much stuff he needs to mix to fill the orders he needs. On the face of it, this is really simple. Just work out how much dough you need, then work out what quantities to mix to make that much as well. Easy. You can do it with pencil and paper, or in traditional baker's fashion, by scrawling with your finger on a floured workbench. And that's how he coped for a few days or a few weeks early on. But he kept making mistakes, which makes for an inconsistent product. Like bread is very forgiving. You have to work quite hard to make something that isn't bread, but consistency matters. So he needed to automate. So he had been one of Bread Matters baking for a living courses, and as a part of the course materials, he had received a copy of spreadsheets that would be used to go from a list of orders to a list of ingredients to mix alongside accurate costings and other useful bits and bobs. And that was great, certainly opened his eyes to the possibilities for automation of this part of the job. And then he tried to add a new recipe. Spreadsheets aren't his favorite computational model, so maybe it was just his lack of experience with them, but adding a new recipe was like pulling teeth. Lots of tedious coping, pasting, and repetition to formulate. So it seemed wrong, especially as the underlying computations were so straightforward-ish. So here's a recipe example. Then a little bit further down, you read, it's the nature of business that you need to keep records. How much got baked? How much sold? Did we clean the floor? Were there any accidents? What sort? How do we prevent them next time? The list is endless. It all needs to be recorded for both legal and pragmatic reasons. So he started a daybook. So this is just a .org file, and every day he comes into the bakery, runs org.capture or -capture, and gets a template for the day's entry in the workbook, which he fills in as the day goes on. So here's an example code. There's also SQL involved now. And then with the cursor somewhere in the code block, Emacs will run that SQL script. The bakery databases will run and populate a table like ingredient columns and quantity columns. So now we're getting really deep into the more computational stuff of baking. So here's more code for org mode in Emacs. And next steps. The software isn't done, of course. No software ever is, but it's good enough that it's been managing his mixes without a hitch for the last few months, telling him what to pack for which customer, and generally removing the need to work anything out with a pencil and paper. It's nowhere near as mature or capable of commercial production and management software, but it fits fine. And he understands what it does and why, how it does it, and the limitations of it, and how to work around them. When it becomes annoying enough, he might sit down and work out how to fix it, but he'll do that when he's in the right frame of mind. So he has a couple of things in mind, like accounting, parametric recipes, better scheduling, order management, and that's pretty much the whole story. There's a bit more in the blog post, but it's interesting to see that really brick and mortar store like a bakery could also benefit a lot from computation and automation.
Yeah, and it's just interesting to watch, computer people solve non-computer problems in a way that's very different than how people who aren't into computers would do it.
Oh, yes.
But, it's usually my first instinct when I'm running into something like this. It's like, I can just use all these tools I have to solve these problems for me. And
apply them to a problem space that they weren't originally written for. And that makes the flexibility very nice. Yeah.
It's, one of the points of being in computers is being able to apply the stuff in ways people haven't done before.
And I mean, the big bakeries certainly have all this automated by now with machines and, all order booking systems and all that. But as a small bakery, it's still beneficial for you, so you don't have to keep everything in your head.
Yeah. I used to play a video game that was basically this.
Where you have to manage?
Pizza Tycoon.
Pizza Tycoon, yeah.
And you ran a pizza restaurant, and you had to make sure you ordered the right ingredients, and you could get discounts by signing a contract to get X amount of ingredients every day or every week.
Delivered, yeah.
But if you ended up with too much or just demand changed and all of a sudden nobody wanted pineapple on their pizza, your pineapple would go bad. Or, you demand would go up for something, because of a holiday or something, and you wouldn't have enough and you'd have to go buy more, but you'd pay a higher price because you didn't have it in the delivery contract and so on.
Yes. Wasn't that also the one where we could bomb or sabotage?
Yes. You could sabotage the competition and things like that, yes. Or you could just be an arms dealer and have your pizza shop only be a front.
Yeah, like the mafia.
Anyway, on to the next story. That has nothing to do with any of this. The ultimate guide to giving memorable tech talks.
Oh, interesting. Yeah.
Yes, always a thing I've been interested in punching up my talks. So the post is by Nina Zakharenko, who is a senior cloud developer advocate at Microsoft. But she has some very good tips on how to make the best talk. So it's actually a number of kind of separate posts, but the first is an introduction to learn a little bit about the speaker if you're interested in that. Then some ideas on how to pick a topic. I know for a bunch of people, they're like, sure, I would love to give a talk at this conference, but I don't know what to talk about. So there's a whole chapter on just helping you decide what type of things you care enough about to give a good talk about. Because it turns out to give a good talk, you have to actually care about the subject to begin with.
Oh, yes. Yeah.
Then you have to write the conference proposal and how to deal with the call for paper process and actually submitting the talk. Michael Lucas has a bunch of good notes on this from his years on being on the BSD CAN program committee. With I think some examples of, what's a good proposal versus what's not. You have first, most important thing is also just read the actual call for papers. Some of them, or call for proposals, some of them are very specific about what they want, and you have to make sure you actually answer all the questions they ask and so on. And you really can't go wrong with giving them more information.
Be very verbose.
Yeah. Well, not verbose. You don't want to pad it out, but you want to make sure that you're giving them all the information they need to know that, your talk is one that they're going to want. Then it talks a bit about tools, if you like that. How to brainstorm, how to come up with slides, how to do time management, because, you don't want to be working on your slides at the last minute. So basically how to plan out all of this. And then part of that is also the planning and time estimation. If you're going to propose to write this talk and get accepted, you want to make sure that you're going to have enough time to actually complete the talk for the deadline and so on.
Yes.
And so how to actually plan and estimate how long it's going to take to give the talk and to write the talk and so on. I've seen people show up and have more material than they could have ever possibly given in the time slot they had of 45 minutes or 60 minutes. And also people show up and only have 8 minutes of content that they somehow thought was going to take an hour. And so it's not only estimating how much work it's going to be to build the talk, but also how much time it's going to take to deliver and so on. You have to remember, when you're nervous, you might talk faster like I do, or you might actually
spend more time on one slide
and take longer. Yeah. Then only then we are down to step 6, which is actually writing the talk, how to make the talk interesting and how to make good slides. And then step 7 is practice and delivery. I definitely think one of the biggest things is practice. My talks I've usually given to the mirror a couple times, and also even, I make my girlfriend or somebody sit on the couch and I use the TV instead of a projector, but give the whole talk. Especially sometimes to also make sure, if I'm giving a talk like the intro one I did at FOSDEM for how ZFS caching works, it was designed, explained it to me like I'm 5 years old, making sure that I wasn't glossing over a point or something. Somebody who's maybe heard about ZFS a bunch, but doesn't actually know how it works. Did they actually understand what I was saying?
Yep, that's important.
Yeah. So anyway, lots of detail in here. I recommend checking it out and improving the quality of your talk. I know also, talking to Philip Pips from the FreeBSD Foundation, some conferences are also starting to actually want you to give a version of the talk to them over something like Google Hangouts or Skype or a video conference, basically, so they can gauge how you're doing and give you feedback so that you can maybe fix things in your slides or in the way you're delivering it before it's actually time to present the talk to the audience.
Yeah, this improves the actual talk for the live audience in various ways.
Yeah. As someone sitting in the audience for a talk, you can almost definitely tell whether someone has practiced their talk before or not. And, there's not really any excuse to have not practiced it.
Yeah. Okay, that's the talk part. And next up, we have Lightweight Contexts, an OS abstraction for safety and performance from 2016. This is a paper at the various people contributing from the University of Maryland Max Planck Institute, and Saarland Informatics Campus. Okay.
Yep. But if you just look at the abstract and maybe some of the introduction.
Mm-hmm. So the abstract reads, we introduce a new OS abstraction, lightweight contexts, or LWCs, that provides independent units of protection, privilege, and execution state within a process. A process may include several LWCs, each with possibly different views of memory, file descriptors, and access capabilities. LWCs can be used to efficiently implement rollback, like process can return to a prior recorded state. Isolated address spaces, LWCs within the process may have different views of memory, isolated sensitive data from network-facing components, for example, or isolating different user sessions. And they have privilege separation, like in-process reference monitors can arbitrate and control access. LWCs can be implemented efficiently. The overhead of the LWC is proportional to the amount of memory exclusive to the LWC. Switching LWCs is quicker than switching kernel threads within the same process. We describe the LWC abstraction and API and an implementation of LWCs within the FreeBSD 11.0 kernel. Finally, we present an evaluation common usage pattern including fast rollback, session isolation, sensitive data isolation, and in-process reference monitoring using Apache, Nginx, PHP, and OpenSSL.
Yeah, so that sounds very interesting. It kind of reminds me partly of some of the ideas Google originally had for trying to use Capsicum in Chrome so that when you're on a Gmail page and there's an image attached to an email, that the code processing and displaying the image wouldn't be able to see the text of the email in case it contained a Trojan or something. And that while you could use Capsicum in separate threads or whatever, something like these lightweight things, and it has a bit of the kind of cherry idea of, you two different threads or whatever, or lightweight contexts have different pointers that's actually the same memory. But this way they can't use each other's pointers, and that you can have access control as part of that. So, this process has read-only access to the memory of the picture in the email. So it can't modify it to trick some other thread into doing something, and so on and so on. So it's a very interesting idea. And the main reason I added it to the show notes was that they did it on top of FreeBSD.
Yeah, you don't see that very often in papers, unless they're UNIX papers, of course. This rollback feature also sounds interesting.
Yes, being able to take a process back to what it looked like before is very interesting.
Mm-hmm. So yeah, we link to the full paper.
It's kind of a disaster recovery thing, right? You can go forward. Oh, we ran into an error. Go back and go the other path or whatever.
Yeah, it would be interesting if the process writes data. Does it also revert?
No, it wouldn't do that in this case.
Yeah.
But if you think of a web app, you could do some of the setup of getting ready for the next process, then snapshot that basically, or bookmark it, or whatever they call it in this context here. And basically you would clone that context and process a request. And then you could either throw that one away and reclone it, or roll it back so that it's ready to service the next request, but with no leftovers from the request that is already finished.
Yeah, definitely interesting concept. Okay.
Yeah.
Very nice.
Be interesting to see this taken further and possibly upstreamed.
Yeah, there's probably future work in that, and something that we will present somewhere else maybe, or at the BSD conference perhaps.
Yeah, looking forward to seeing more from that.
Time for BSD Bits this week. We have May 7th, BSD Users Stockholm meeting, or meetup number 6. So this is just an event.
So this will be Tuesday, May 7th. They'll be having the next meetup, and it's back where it's been before at the B3 offices in central Stockholm. Looking forward to there being lots of people there. So if you're in Stockholm, you have no excuse. Show up. 6 p.m. to 9:30. And yeah.
Okay, next up we
talk
have
about Unix. It's good times.
Yes, in Stockholm, and they've done it a couple of times now, so you can maybe, if you've been there before, see a couple of familiar faces.
Mhm.
Next, we have a search for help, mostly. There's a sysutil / docker -freebsd, and there's a little message going like this. Hello, everybody. Currently, Decke and Jochen here are working on the update of the port. They try to change it completely to Moby, and then, of course, that the port is working properly. For this, they are still looking for people who want to work on this very large update or later can test the work. And if you want, you can pop into Freenode on IRC, #freebsd-docker, and we try to coordinate it there, because that will bring FreeBSD's Docker support a bit further.
Yep.
So let them know if you're interested. A couple of people replied already, but there's always more people that can help.
Yep. Next up, the cat tax. So you've heard of Midnight BSD. Have you ever wondered a bit more about Midnight the cat? So in case you didn't know, Midnight BSD is named after the original developer's cat. And now there's a video of the cat who is apparently unhappy in this particular video. But it's a BSD cat video, so it's the internet.
Okay, but yeah, maybe we'll see a video of the Dragonfly BSD or Puffy's daemon or any other mascots. Okay, that's settled for the cat tax. Next, we have fixing Unix /Linux /POSIX file names.
Yeah, so this is an update of an original post from 2009, has been updated for 2018 by David Wheeler, and he's looking at things like putting control characters like new line or leading dashes or other things into file names and making them very annoying.
Yeah.
Traditionally, Unix and Linux and POSIX file names and path names can be almost any sequence of bytes. The path names let you select a particular file name and may include 0 or more / characters. Each path name component is separated by a / is a file name. File names cannot contain /. Neither file names or path name can contain the 0 byte. But other than that, that's about the end of the restrictions. The lack of limitations is flexible, but also creates a legion of unnecessary problems. In particular, this lack of limitation makes it unnecessarily difficult to write correct programmings, which sometimes leads to security flaws. It also makes it impossible to consistently and accurately display file names, causing portability problems and confusing users. I know that we've made a couple of sweeps over the years of the FreeBSD SVN repo to try to deal with any files that wouldn't check out on Windows or Mac because of things like, I think in one place we have 2 files that are the same name if you don't consider the difference in cases. And obviously that causes problems. Or I think files that start with a dot are sometimes a problem on Windows because they expect a file name dot something. So anyway, this article will try to convince you that adding some tiny limitations to what is a legal file name would be an improvement. And many programs already assume these limitations, and the POSIX standards already permit such limitations. But the fact that they're not there can cause problems. File names that start with dash can be a real problem when dealing with shell scripts and so on.
Yes, for sure.
So the biggest problems obviously are control characters in file names, like if a file starts with a new line, a tab, or an escape. I've definitely had escapes in the beginning of file names. It is really annoying. Having a leading dash in a file name, which can really screw up the argument parsing of tools. If you're trying to RM a file that's called -foo, RM will be like, all right, I know what -f is, but there's no flag -o or something like that. Or like, you didn't specify a file name. It's like, it did, it's -foo. And, you have to know to put -- to disable all of the flag processing and tell it that everything after that is a file name. He said the lack of standard character encoding schemes, like using something like UTF-8, can also cause problems. These 3 problems impact programs written in any language on Unix, Linux, or POSIX systems. Then we have spaces in file names, although I think we've mostly given up on that fight. But, if we could resolve some of these, it might make a big difference.
Yeah, that will certainly help.
Because I know you can have similar problems. Some of the restrictions in ZFS have not been very good. I think you can create a data set called dot or dot dot, which will cause you infinite trouble.
I shouldn't try this out, in production.
Yes, you shouldn't try that out. And I think some restrictions are going to be added to prevent that, but it's basically the same issue. They have a bunch of examples here of how you can see some of the problems here. They have examples of what bad things will happen if you happen to run into a file name that has a new line in it or starts with a dash and so on.
Can you create a data set that has a slash in it? Just a single slash?
No, because slash is the separator for child-parent stuff.
Yeah. So that checks for it.
Yes.
Okay.
But
at least
dot and dot dot should not be allowed. And I think there's a bunch of other examples that could be bad. And I know in the past, you could, with the share NFS property, you could put a new line in it, which would cause all kinds of problems.
Yeah. Oh, ouch. Yeah. Not good.
So they have lots of references in here and so on. And if you're interested, it'd be worth looking at. I don't know how easy it would be to get operating systems to agree to change how we deal with file names. But I think we can all agree that file names that start with a leading dash are a terrible idea and we shouldn't allow it. But because we have allowed it, it's very hard to change it. And then, the whole conversation on collation and the fact that, a list of files will sort differently on a Mac than it will maybe on BSD or on Linux causes all kinds of very interesting problems.
Okay. Next up, we have Metasploit and OpenBSD. So whether you're a pen tester or do some occasional auditing, most likely you are familiar with Metasploit or have heard of it. It's considered to be an essential tool for offensive security. The author here has always been a little stunned by the fact that Metasploit is often ran from Kali. This is Kali Linux, and Kali Linux is far from secure. Kali takes this to the next level by running everything as UID 0. Offensive and defensive security ought to go hand in hand. So obviously, let's combine these two and install Metasploit on OpenBSD. Puffy for the win. And they describe a bit how to prepare the dependencies, installing Ruby 2.6 because that's a requirement, starting Postgres to do some, because Metasploit requires a database to store the information in, and why not choose Postgres in the first place, and then set up Metasploit itself. So it's basically how to get this done. And then you have your Metasploit running and can do your pen testing.
Yeah, I've installed it on FreeBSD before when I needed to test a fix for a vulnerability, actually. It's like, okay, I want to make sure that the vulnerability is actually fixed.
Yeah, that it's not there anymore. The patch was applied. And next we have run your own email server with NetBSD. So this is a presentation, I think.
Yep. By Amitai Schleier, who've had on the show before, although that was quite a few years ago now.
Maybe it's time for a revisit. So he gave a talk about running your own email server. And first he says, no, don't run a mail server. But then he's more encouraging. Do run a mail server in the following slides, and he describes how to.
Yeah. So first it was don't run your own mail server. It's not your core business or a differentiator. If you're, especially if you're, So don't run a mail server if it's not what your business does. Don't run a mail server if you're trying to run for office. If it would be too much for you to learn up front, or if it requires careful monitoring and easy to maybe save them, but. Google is ending its inbox feature in March, so suddenly maybe you do want to run a mail server.
Yeah, just because of that.
Yeah.
And he talks about how to get started with package source and installing Qmail and related packages and setting other things like MX records. And this is a very, very good start.
The slides are short. It's, I think most of the content was in the talk.
In the talk itself, yeah. Maybe that was recorded and people can get the full
It was
talk.
DevOps Day, so probably.
Okay. Then we have Rdist, which you probably not have heard about. Oh, it's a very dark website in color schemes.
But Rdist is the remote file distribution client. So it's a way to distribute files. So Rdist is a program to maintain identical copies of files across multiple hosts. It preserves the owner, group, mode, and M times of files if possible, and it can update programs that are being executed. Rdist reads commands from dist files to direct the updating of the files. So if you need to keep files the same on a bunch of hosts, Rdist might be the way to do it.
Yeah, take a look and maybe you like it.
Yes, so in this case, the author says that my primary use for this was to have a firewall cluster using grep and using Rdist to keep some of the files in sync.
Ah, yes. That's a good
walk
use
through
case.
setting that up. So if you need to say keep the config files in sync between two hosts that you're carping a service between, it's a good solution.
Next up, we have writing a book with Unix. So this is from the author of Hands-on Bug Hunting for Penetration Testers and describes a little bit why he was determined to set up a workflow that would allow him to keep a backup of the book, allow him to easily track the writing process, work on the book offline, and keep his own copy of the book. And
having versioning, access control, and the portability of the plain text is very useful. Unix is actually pretty good at this because it was one of the things that was done with Unix very early on.
Text publishing.
It was I think it was at Bell Labs, right? It was one of the ways they convinced somebody to give them enough budget to buy a computer was it was some other department that needed a computer for like word processing stuff. And they, so the people writing Unix didn't have enough budget to get a bigger computer, but some other department did, and they conned them and wrote them the software to work on the books or manuals or whatever they had to work on.
And here we are.
Yes. There are a lot of tools for writing books and actually composing and so on Unix, and they're quite good at it.
Yeah, and it's basic shell programming or shell in putting these links together, or each individual chapter is a text file in a directory, and then you walk through the directories and do word counts and remove characters that you don't want and things like that. Very nice, quick and easy. And yeah, next up we have 7 Unix commands every data scientist should know. So this ties into our original one that we have, that we already slammed Hadoop. We might as well help the data scientists a little bit more.
So obviously you have grep to use a regular expression to search some text. Cat, which lets you either just spit some text to the screen, which is what we use it for most often, but not what it was meant for, which was to concatenate multiple files in a specific order into a bigger file, which can be very useful if you need to, say, take 4 data sets and make one big file that you can then use grep or whatever on. Find, which lets you find specific files on the file system. I often use this for, show me all files in this directory that are less than 7 days old to find what changed, or that are more than 2 years old for files that haven't changed, maybe need to be removed, and so on. Okay. Or in this case, it was, examples of find every JSON file, or delete every compiled Python file so that they'll all be rebuilt, or, find every file called setup.py and look for this string in each of those files.
Or find the man page that I'm actually looking for to find this other functionality.
And then obviously the head and tail commands to look at the start or end of a file, whether that's by lines or bytes or whatever. The word count tool, or -L for word count for the number of lines. And you can tell, oh, look, here's these 2 CSV files, and they each have about 100,000 lines, and that's 200,000 lines in total. Awk, which is basically your programming language for text.
Tried and true, yeah.
And they have shuff for shuffling data if you want random permutations of those inputs. So, they start with a CSV file, shuffle it, take the first 50 lines and make a sample of a random file. Or, in this example, find every file in a directory, shuffle it, take the first 5. So now we've just found 5 random files from that directory, and then copy them to a sample directory. And now we have a random sampling. And they also cover xargs, man, and a bunch of other stuff.
Yeah, knowing these will already get you quite far in your data processing.
Yep. So next up, they have explaining code using ASCII art. He said, people tend to be visual. We use pictures to understand problems. Mainstream programming language, on the other hand, operate almost completely in an abstract space with just text. This piece is about pictures drawn using text character sets and then embedded in source code. I know I've seen a lot of these in ZFS, and they're quite helpful.
I thought you would mention that, yeah.
So here's some examples from LLVM, where they show where you enter and then stuff happening. Or in the JIKES RVM, shows some stuff like this. There are diagrams that look like this that explain some of the data structures in ZFS. You can actually see, what a block pointer looks like on disk and what the structure in memory looks like, and how some of these members actually point to other types where there'll be a different diagram. Or here's the tree rotate function in the Musel libc, and showing how that works.
Oh yeah, there's a lot of examples in here. Yep. Wow.
Well, it turns out it's a good way to explain stuff.
Oh yeah, and you don't need a graphics viewer to just display them. You just open a text editor or just do cat and you have it.
Yep, or a state machine showing all the possible transitions. Lots of things like that. If you're trying to draw one like this one here, the IOStream, ASCIIflow.com has some good tools for drawing this kind of ASCII art instead of trying to do it all by hand. Unless you use the mouse to start drawing it and move stuff around, and then you can, final editing probably still going to happen by hand. But
And the next thing, if you want to go away from the ASCII art but still want to describe your picture in text, then you would go start working with GraphViz.
Yep. Or here's one. I actually managed to make a reasonably looking curve just out of ASCII art. This is balancing memory management objectives in an OS kernel. There's a similar kind of graph in ZFS for the right throttle, showing how, when there's not much data waiting to be written, there will be no delay. And then once we reach a certain threshold, as more and more data is waiting to be written out to disk, we'll start adding a small amount of delay to keep the application from just filling up memory with dirty data that the disk can't keep up with. And then when we reach a certain spot, we'll actually stop the application and make it wait until some data actually gets written, so that we don't just accumulate forever. Anyway, they have lots of really good examples in here. So if you're wondering how to try to draw some of the stuff, they cover it. Even just this basic one that just documents the structure of the different components of a URL. You have the scheme, which is the protocol, the username and password, @ the host name, : the port number, / some path names, then the query string separator, your query parameters, and then your reference with the hash mark and so on.
Yeah, there's a lot of things you can do with simple text and characters.
Or this one that shows the undo system in Emacs, including what happens when you undo, and then undo.
Where am I now? With the original one or the undid one?
Or here, they got a great example, the attitude control system for the Apollo guidance computer.
Yeah, way back when they didn't have much fancy graphics.
The moon, exactly. Or here's one on how you can tilt an image in C and so on. Lots of good ones. Anyway, next up.
Yeah, we have 2 hackathons we want you to know about. So the first one is in Aberdeen in April. And this is from the 17th to the 19th at the University of Aberdeen in Scotland. And we are still looking for a couple more developers or BSD aficionados there. So if you're interested, the wiki page has all the information about the logistics and how to get there and how to register. And yeah, this is, I think, a nice thing because it hasn't been done before in this location, and it's a good excuse to go to Scotland, if only that.
Yes, and I know Tom has a bunch of fancy networking equipment, and they would be very interested in anybody who wanted to work on networking coming out to that. I think they have like some 100 gig stuff that they want to play with and so on.
Mm-hmm. Yeah, it's not completely networking focused, but if you have a network knack...
But Tom is organizing it, and Tom is network focused.
Yeah, definitely. So yeah, consider this. This might be interesting, and there's also a bit of hacking involved and learning about the system. The next one is a more security-focused one in Vienna in June. This is also a new one this year, so we're starting up on our hackathon game in the FreeBSD world at least. And so if you're interested in that, then this is from the 8th till the 9th of June. This is over a weekend. It's a long weekend because there's Pentecost in front of it, I guess, or around it. And so the Monday is still off, and they also said there will be a little bit of tour of Vienna if you haven't been there, like me. And so this is a nice way of, for the European folks to hang out and do a little bit of security work, whatever that might be, hacking or trying to fix bugs or whatever what comes up. There's also information on that website, and there's registration for this. And yeah, if you have a question, contact the organizers, then we'll have a bunch more people there. Okay, that's our Beastie Bits for this week. And before we start our feedback and questions section, we have to, of course, ask you to actually get us more questions and feedback, because we hit that low point where we're running low on your questions. So if you have any questions for us, send them to feedback@bsdnow.tv, so this section will not be empty in next week's episode. So get on with the questions.
We recorded a lot of episodes early to cover the fact that I was going to be away for like 3 weeks. So yeah, we've used up the entire backlog. We were, only surviving on scraps now. So if you could send us more, we would really appreciate that.
Mm-hmm. So the first one this week is Mike with FreeBSD update and erased EFI files. Ooh, sounds scary. Goes like the following. Hello, gentlemen. We recently performed a normal FreeBSD update fetch and FreeBSD update install to update my FreeBSD 12 server. The OS never recovered from a reboot. Ooh. After some wonderful help from the FreeBSD IRC channel on Freenode, I found out that all the files on the EFI partition were removed. I was able to recover my system, but do you know if the update process rewrites the files on the EFI partition? Also, is there a way to protect the computer from the files being removed?
Right. So I think I've talked to this guy via email after. It was not FreeBSD update that did this to you. So don't blame FreeBSD update.
Who did?
Part of the problems when people report problems like this is they forget other things they also did. That's why I recommend doing what Dan does and writing a blog post or a GitHub gist or whatever of each thing as you're doing it with the output. So if something goes wrong, you have something to refer back to. Mm-hmm. So it was actually running zpool upgrade that caused the problem. Now, not zpool upgrade itself, but after you upgraded your kernel, you ran zpool status and it said, hey, you should upgrade your zpool to get the new features. And you did. And then it said, don't forget to update your boot code. Here's an example of what the command might look like. And you blindly copy and pasted that. So that example was written assuming you're booting not EFI. So by default, what the installer does nowadays is actually install both the BIOS and EFI boot codes in separate partitions. But because reasons, it puts the non-EFI one second. But the example still says, run this command, which will overwrite the first partition with the new BIOS boot code.
Which you're not booting from.
Well, you might be. I don't know how old your pool is, and so on.
Yeah.
The zpool command has no way of knowing which partition is which and what you should do. It gives you an example and says, make sure you put the right device names for your system and so on. But yes, you have to indicate the right partition on that device as well. And so you overwrote your EFI partition with the BIOS boot code. So what you want to do is make sure you update the FreeBSD-boot partition, whichever number that happens to be, with the BIOS code, and that you update the EFI partition with the right EFI code.
Yeah. Gpart show can show you those
yes, we'll help you
IDs.
And we're working on making this process easier now that we have some of the EFI tools. And we're going to keep making it better. And I'm hoping, not to spoil my talk from Asia BSDCon, but I'm hoping on maybe actually having a zpool boot code command that will do the updating for you by actually finding each disk that's part of the pool and updating it. Or in particular for BIOS, for non-EFI booting, actually keeping the boot code not in a separate partition, but in an available space in the ZFS boot code area. And then Thomas Soom from Illumos has already made an extension to ZFS where when you use zpool create, it creates an EFI partition for you that ZFS will know where that is and be able to update it safely. So hopefully in the future, you'll be able to use the zpool bootcode command and it will update all of your disks safely. Although that's still just an idea in my head. No code's been written yet. And it's part of my talk is, all right, so we need to do that, but we also want to have a way to fall back if the new boot code doesn't work properly and so on. And so there's still a lot to be discussed there.
Okay.
But anyway, yes, be very careful after you do zpool upgrade when you're updating your boot code that you install the correct boot code for your system and that you install it to the correct thing.
Okay, I think that covers it. So you had to email contact with him and figured it out so you can boot his pool again?
Yes, it's all sorted.
Okay.
It was just boot off the live CD and run this command to install actual EFI code into the EFI partition.
Yeah, this will get at least your system started again. Okay, thanks for that question. Charles
the next one's for you, so I will read it.
Oh, go ahead. Go ahead.
So sure. Charles writes in about volunteer work. He says, "Hi guys. Listening to one of your recent podcasts, it sounds like documentation is starting to fall behind. That's sad to hear since documentation has always been a strong point of FreeBSD. If I recall correctly, Benedict is on the documentation team. Can Benedict, or possibly anyone else, direct me to someone who can outline a few tasks that I could do to help?"
Okay. I see where this is going. Yeah, so first, thanks for volunteering or volunteering your help in the documentation area. So there are small things and some bigger ones that are probably better with someone that has a bit more experience under their belt. But there are small things like run a link checker, for example. There's a couple of broken links in the handbook, and we get reports about these from time to time. And if you can maybe periodically check the sources for broken links that don't work anymore or point somewhere else.
Other thing is, like, if there's a part of FreeBSD that you happen to know reasonably well, just making sure the documentation for that is up to date. And if it's not, make patches and send them in.
Yeah.
That's how I started.
Yeah, it's small things. There's a comma missing, or there's a sentence stop not completed or whatever. Then let us know or send it to me directly. We can also talk directly about how you can get more involved in the project or in the documentation area. This is certainly an avenue into the project or doing documentation work. There's also talks about doing, there's a program from Google called Google Summer of Docs this year where we're trying to participate. So maybe there's an avenue for people to write documentation in this part. And yeah, you can also look at the Bugzilla database for documentation bugs that you can work on. Maybe something needs to be rewritten or a section needs to be updated with newer commands or some different output maybe. So there's a couple of bugs in there that are also worth looking at as someone who is not into the documentation team already. But yeah, if you want to know more, then definitely send me a private message, send it to me or send it to my freebsd.org address. It's bcr@freebsd.org. And we'll talk further there. Okay, thanks for that question. That was unexpected, but yeah, it's good to have help in the project in documentation areas. And Jake is last but not least with a Beehive front-ends question. Short and sweet, do you guys use any kind of front-end to manage your Beehive VMs? If so, what do you use and why?
Yes. So I don't use much. I don't use Beehive very often currently, and when I do, it's for debugging kernels and so on. And so I am actually invoking it manually. But what do you use?
I use VM-Beehive, or used it. I think last year when I had to use it on the cluster because we didn't have enough machines, so I had to run multiple Beehives on one machine, which worked pretty well. And the management interface helped me kept saying about which is the machine that I need to reboot. Is it that machine or the other one? Mm-hmm. So the more machines you have, the easier it is to have a front end. But this is not a graphical one. It's just on the command line, like list all your VMs and show what network interfaces they have or what IP addresses they are associated with. But it's nice and sweet, and I think it's still working with the current Beehive versions. So that's one. There are other ones.
There's lots like CBSD, IOHive, Chives. There's tens of them.
Yeah. Try out the ones that you find best and use those. That's my recommendation, as long as they support
can depend
features.
What you want to do. I don't know which ones are the most actively developed. Be a good question. Maybe it'll come up at the BeehiveCon. That's has already happened when you're watching this, but when we're recording this, it has not happened yet.
Yeah, maybe there's some news there, and the more people are using Beehive, the more machines they have, and the more the need for a management interface comes up. So that's something.
Because I might look at one of them, because I do want to stand up a permanent Windows VM for Scale Engine for when we need to use the Java IPMI stuff. Using my old laptop for it is convenient at the office most days, but it'd be nice to have a Windows machine that we could remote into when you're, say, in Japan and bring the extra heavy laptop with you.
Yes, yeah. Problems some people have, yeah. But definitely a good use case for Beehive, so that's a good thing to have. All right, that pretty much covers this week's episode with all the news for this week. Thank you for watching, and see you next week, where we probably talk a lot about Asia BSD Con that just happened.